Welcome to part 1 of the partial screen shake shader tutorial in Unity by PeerPlay. In the previous part I explained the shader we are going to create and how to set up your project. In this part we will start with creating the shader. If you find the contents of my tutorials helpful, consider supporting me at Patreon. In doing so, you enable me to create these for my peers and you get access to the tutorial source files and exclusive content. Special thanks to WayneGlows.
So I had this great idea of making a very nice environment together for a scene to create the shader on. But I guess I'm not an environment artist, so we'll just download the 2.8 gigabyte file that I used.
The name of the asset is Unity Terrain URP Demo Scene. You can find the link in the description of this video. As a disclaimer, it's over 2 gigabytes download, so if you don't have the bandwidth, find an alternative environment or create one yourself.
It takes so long for Unity to import, so I'll sing a little song. Just pour yourself a cup of tea, and before you know it, you will see that it's done. Now that everything is imported, let's open up the scene. So go to Scenes in the Terrain Demo Scene, and let's open up that scene file. As you can see, everything is black. That is because of my post-processing template. So we need to add the template here, and then we can set this up higher. Now let's first remove everything we don't need, like these bookmarks, this one, we don't need a camera. Remove the timeline, events, this one, everything can go away, and we'll keep the rest. Now let's go to the naughty character, go to prefabs, and drag the Ellen character into the scene. We need the camera rig, and we need the player input system. Now let's go into the assets folder and we'll remove some folders that we don't need, like the tutorial info. Yep, we can remove that. We'll remove the new terrain. Now select the Ellen character and press F on the keyboard with your mouse in the scene view. And then we can look at the character from up close, because the materials for this character are not set up for the universal render pipeline, so we need to change them. So in the materials folder of Ellen, just select everything, and we're going to go to select different shader for the universal render pipeline. I'm going to set that to lid. Now everything's set to white, and that's because the base map is now unlinked. So if I click here, then I'm in the folder, and I'll just drag the albedo to every one of them. I'll pick a hair color for this. Mine was blue. That looks better. Now let's test out the scene if everything's working. And yes, we can walk around with our player. Great. Now let's save the scene. So go to Save As, Scenes, and we'll call this Screen Shake. Now go to the assets root folder, and here we have our 3 files from the template. We can get rid of this readme. Let's create a new folder, and we'll call this folder Resources. Now I want you to place the shader into the resources, and this is because our post-processing shader is not being referenced anywhere in Unity. So if you're creating a build, it could be that Unity does not include it in the build, and then the shader doesn't work when you create a game. When you put it in resources, it will always be included. Now let's create another folder, and we'll call this Screen Shake. Let's put these 2 files inside of that folder. Now let's have a look at all the files. So let's first go to the resources and do the shader that we have for the template. And we're going to rename everything to match the screen shake shader that we're going to create. So let me rename this one to screen shake. it won't work anymore then because the reference is not correct anymore. But we'll fix that later in our scripts. In the shader or here, you can see that it references PeerPlay as the folder and then the screen shake as the name of the shader. We need this information to reference the shader in our script. Before we're going to work on the shader itself, let's first look at the files here. We have the temp settings and the temp render feature. Let's rename the temp settings to screen shake settings. And the temp render feature is going to become screen shake render feature. Okay, so what are these files? Screen shake settings is the settings that we put on the post-processing volume, like these ones. So this one is just a container for some settings. And the screen shake render feature is the one that we need to apply at the settings our renderer. So we have the high fidelity renderer, and here we can add that render feature to it. Let me remove this one now because it's missing, because we changed the name. Now let's open up this screen shake settings. So let's go through this script. So we're using Unity engine, we're using the rendering library and the rendering library of Universal Render Pipeline. This is needed so we can find the volume component, these components that we need for our settings. And the only thing we actually have to change in this is this name, and we'll change this to screen shake. Oh, and actually the name of the class as well. Screen shake settings. We can leave the rest as it is, just press Ctrl S to save it and go back to Unity. Now let's open up the screen shake render feature. Let's minimize this class. And we'll change the name to screen shake renderer feature. Now essentially the render feature is also a container that contains shader passes to update to the camera texture. So one of them is the temp render pass. This shader only has one pass. And we're going to rename this as well. And we select it and then we press Ctrl R for rename. And that way we can rename them all at once. So I'm going to change this one to screen shake render pass. Same thing for the name, double click it, Ctrl R, and rename it to screen shake render pass. Now in create, it says here temp, and we're going to change that to screen shake. Now let's click the plus here to open up the screen shake render pass. Now we've got here the temp settings, which is the other script that we have, and we renamed that to screen shake settings. So we're going to rename this as well. And we're going to change this to screen shake setting. You'll see in the setup that it's still saying here get component temp settings. So we need to change that to the screen shake settings. Let's change this temp text to screen shake text, and the temp text ID, we'll change that to screen shake text ID. Now inside the setup, we can see that the material is becoming a new material, and it does a shader.find, but right now it can't find the shader because we renamed that to screen shake. So let's type screen shake here. Let's scroll a little bit down to the configure. We'll change this name to screen shake again. Now I see that I didn't update the temp text. So let's scroll to the top and double click this, Ctrl R, and we can change them all at once. And we'll call this screen shake and apply. Now let's scroll down to the execute. And the only thing we need to change here is this temp, and we'll make this screen shake. Now this is the part where the script actually talks to the shader. You see here the material sets the float intensity. It's the intensity float of the shader that we're creating. And here it's getting the screen shake settings, and it's getting the value of the value intensity. And it sets it to the shader here. And then it blits. And then it goes into a temporary texture using the screen shake shader. And it's pass 0. We only have one pass in this shader. And then next it's putting it back into the source. So the shader is applied. So I believe that's everything we need to change in the script for now. So let's hit Ctrl S to save it and go back to Unity. If you've done it all correct, you should see no errors in the bottom. Now let's add the render feature again to the renderer. So we'll click Add Render Feature and you should see the Screen Shake Render feature. Now go to Post Process of the volumes, add an override and select the Screen Shake. And it appears to be working. Let's save for now. Save the project. 11 minutes into the video and let's finally start to work on the shader. So here we're inside the Shadergraph editor. On the right you see the game screen view. So we can easily see the changes that we do to the shader onto the game view. Now this main text is actually the incoming texture on the camera. Everything that's already been drawn and all the post-processing effects that have already been applied. So if I change this to, let's say, main text 2, then it won't work anymore. It will just be a white screen. So we have to call this main text in this way with the underscore main text in the reference. So we're going to apply a screen shake effect, and for that we need to get the screen position because we're going to offset the screen position. So press spacebar to create a new node, and we're going to type screen. And then we can see here, input geometry, screen position. Now the first two values of this vector 4 are the X and Y values of the UV space of the camera texture. So it's actually the same as the UV texture of this main text. And you can see this if I connect this one with this UV. And if I then save it, then the result will be exactly the same. Now we want to offset this screen position before it's inputted into this UV2. Let's drag this a little bit out, and we're going to add an add component. Now we can connect this one, it becomes a vector 4. And now we can change the X and Y components here. So if I change the X component to 0.1, so that means that the screen position is going to be extended by 10% of the horizontal space. And let's also do this for the Y component, 0.1. And then add this back. Now let's see what that looks like. Let me make this a little bit bigger. Now the camera is showing the result of 0.1 on the left to 1.1 on the right, and 0.1 on the bottom, and 1.1 on the top of the screen. The pixels beyond 1 and below 0 are unknown to the camera, so it will try to fill in the space by extending the last known color on its axis. Now our screen shakes won't shake with this great distance and won't be shown for a very long time, so it will not be as noticeable. But this is not the ideal situation, so don't worry about this. In the final part of the tutorial I will show you a way to fill in these missing pixels. Now just to be completely clear, so if I change the X component to minus 0.1, then it will appear on the left side. Now to create the shake effect, we're going to calculate random numbers that we can input here. Let's clean up the shader a little bit. So let's take away this one. We don't need the multiply. Instead, I'm going to add a lerp. Now the output of this main text is the original texture, so I'm going to put that into A. I will be disconnecting this line, so it will be the original texture. Then I'm going to get a new sample texture 2D. I'm going to duplicate this main text, put that on here, connector offset, and put this one into B. And the intensity is going to be the time. And let's reconnect the lerp with the base color. Now save that. And now we can use the intensity slider to slide between the original picture and the offsetted picture. Okay, let's now calculate random values. So instead of these values, we're going to input these random values. So let's hit create a new node and we'll type in random, and we need the random.range. Now the random.range has three different inputs, a seed, a min and a max. So the output, this is the output, the minimum output and the maximum output. And we want to output a screen shake that goes into the minus values and the plus values. So the output for the X will be -1, and the other one for the max will be 1. Now this function creates a random number based on a seed. And this seed has to be different all the time, because if we input a same seed number, it will always output the same number. So to make sure we always have a different output for the seed, we're going to use the time. So let's create time. Now create a vector 2. And we're going to put the time value into the x of this and connect this to the seed. Let's put this nicely next to each other. Now let's select everything, copy, and we're going to paste it. And now instead of the x value, we're going to use time for the y value and remove this one. And now we have two different random values for the x element and the y element. So then we can be sure that the x offset will always be a bit different than the y offset. Now to create the screen shake effect, we need two different values for the x and the y component that we can then set at 1, and then the strength will be lower and lower, and then the screen shake will be gone. So let's go to the plus here and add a float, and we're going to name this shake strength x, and let's add another float, and we'll call this the shake strength y. Now let's create a multiply and another one, and we're going to put this shake strength here and this one here. Let me close these ones because I'm going crazy. And now connect this one here. We'll connect this one here. We'll connect this outcome into the multiply. Same thing for this one. Now I'm going to rearrange everything nicely. Now we want to add this outcome to the screen position, and the screen position is a vector 4. So we're going to add a new vector 4, and we'll add the x component to the x, and this one is for the y. So we'll connect that there. Let's select everything and press Ctrl G, and we're going to group this, and we'll call this random shake x y. Now we can select this whole thing, and the output of this vector, we're going to put this into here. Now the outputs of this vector will be between -1 and 1, and that is way too much for shakes. So we need one more parameter to control how much percentage we want to offset the screen. So let's create a new float, and we'll call this float the offset percentage. Let's drag that into the screen. We'll hit spacebar and type MUL for multiply, hit enter, and we'll connect this one to A and the percentage to B. Now connect this to the add. Let's see if I set up everything correctly. Seems to be okay. So let's save this shader. Now we don't see any offset happening in the game view, and that's probably because the settings are set to 0. So if I set the shake strength to 1 and this one to 1 as well, and if I set the offset percentage to 5, wait, this is not percentages yet, because 1 is 100%. So we need to divide this number in the shader by 100, so this value makes more sense. So we've got this value here. Let's do a multiply. And a multiplication is way faster than dividing. Put this one in here. And we're going to multiply this by 0.01. Yep. And then we're going to put that back. Now save the shader. Now you can see that the screen is shaking with an offset of 5%. So if I change this number to 25%, seems to be working. 1%, that looks pretty good. Now let's add the parameters that we've created to add it to the screen shake settings so that we can control it by sliders or by script. Let's add a public. I'm going to add a no interpolation clamped flow parameter, which means that this one is not affected by the changing of the weights of the global volumes. And we'll call this shake strength x is a new no interpolation clamp flow parameter, and we can copy paste this stuff. We want the initial value to be 0 and the minimum value 0 and the maximum value to be 1. Now let's copy this line, paste it, and we'll change this to y. And now we'll get another one, and we'll call this the offset percentage. And this will be a minimum of 0 and the maximum will be 100. Let's actually put this line above the shake strength. Makes more sense. Now I hit Ctrl S to save. Now let's go to the screen shake render feature. And here we need to add lines to apply these values to the shader. So we'll say material.setFloat. If you want to make sure that you have the correct reference name, then you can click on this one and get the reference. Copy this and paste it here. And we want to set it by the screen shake settings dot the shake strength X. So its value. Now let's copy this line, paste it, change this to Y. Let's do the same again. Get the offset percentage, paste it here, and we're going to change this to offset percentage. Now that should be all. Let's hit Ctrl S and go back to Unity. Now the cool thing about this, we don't have to be in play mode to test out the settings. So if I set these values to 1, then we have the offset percentage, and we can check out a little bit of the result. It will go a little bit slower. No, it's because I selected it. And I just found out that I made an error. Because the shake strength Y doesn't work. And why doesn't the Y work? Because I set the X here and not the Y. So let's save that. And now it does work. So it's only going in the Y-axis. And now it's only going into the X-axis. That's it for this part. In the next part, we will create a controller to spawn screen shakes and add a function to offset the screen position by noise. Thank you for following so far, and I'll see you in the next part. To stay updated with new content, subscribe to the channel and turn the notifications on. Happy coding!